Hey everyone, it's Mr. Levin. I'm back here with Lesson 4 on iteration structures. I'm back here with Lesson 4, iteration structures. I'm back here, just kidding. I'm repeating myself because iteration means repetition. In this lesson, we're going to be learning how to do all the different types of repetition that you'll need in Python. This is an important lesson because we're going to build on it in the lessons after this one. We are repeating over lots of different types of data. Iteration structures is where we really start to unlock the power of a programming language, right? Because computers can do things really quickly. And so when you write code that repeats itself, then you start to see and harness the power of a computer to repeat operations thousands of times in the blink of an eye. So we're going to look today at how you do iteration structures that you've seen in Scratch, and then what they would look like in Python. And then we'll also talk about what they would look like in AP pseudocode. But for today's lesson, for the first time, we're also going to do a little bit of coding together so that you can code along with me while you practice using some of these iteration patterns. So the first iteration pattern I want to talk about is the until/while loop. Okay, this loop in Scratch says repeat until x is greater than 10. So you're repeating until this becomes true. Right, in this case, x started at 1, and then we change it by 1 each time. So we're adding 1, we keep repeating until x gets to be greater than 10. In Python, we don't have a repeat until. Instead, we have a repeat while. While this is true, continue repeating. So it's sort of like the opposite of repeat until. And if you want to have the same effect, then you have to switch your comparison operator here. So in Python, to do this same loop, you would say while x is less than or equal to 10, right? Another way to say while is as long as. Whenever I'm reading while in Python and I want to think about it in my head, I read it as long as x is less than or equal to 10, keep repeating. So we print, and then we add 1 to x, and you keep updating x until eventually this will no longer be true, and then we'll jump past the while loop and down to the next statement. In AP pseudocode, we do have a repeat until. And this is what it would look like. You'd have the parentheses around the condition, and then of course your curly braces and your indented code. The other type of iteration that we want to talk about is the repeat or for loop. This is more useful when you know exactly how many times you want to repeat your code. Right, in Scratch, we actually could just put in the number, and then we would repeat that many times. In Python, we're going to use something called a for loop. So you would say for I in range, and then you put the number 5 in here, and then underneath it, again, you have the colon, and then underneath it, you have the body of the code. So let's break this down. You have the word for, and then I is actually a variable, and then in is a keyword, and then range is a function that's actually going to give us a range of values from 1 to 5. And we'll talk about range a little bit more later in this lesson, but for now you should know that what this is going to do is actually repeat 5 times, and then I is going to have the value 1, 2, 3, 4, 5 as we repeat. In AP pseudocode, very similar to Scratch, we have a repeat x times structure that we can use to repeat a specific number of times. So the range function that I mentioned a second ago is useful for creating a range of numbers. And basically it's going to create a range. If you just give it 2 numbers, then it's going to create a range from the first number to the last number. But this last number is going to be exclusive. So for x in range 1 to 5, we actually have x taking on the values 1, 2, 3, and 4. In our second example of using range, we can actually pass in 3 parameters. So to pass in 3 parameters, you have the starting number, the ending number, and this is going to be the increment. So basically what that means is that we're going to, instead of counting by 1s, we're going to count by 2s. And we could change this number to be anything we want. We could actually count by 3s, 4s. You could even count by negative numbers. And you'll see when you try playing around with this how that would work. But the idea here is, again, that we have this structure where you have the word for, you have a variable, in this case it's elephant, keyword in, and then range is the function, and then we pass in our parameters, and our code here, our iteration structure, our for loop is going to repeat for each of the values in that range. So in this case, that would be 2, 4, 6, 8, 10. All right, let's try it out together. Now I'm going to switch over to writing some code.
Welcome everyone. I'm going to go over the for loop, the while loop, and then jump into some of the examples. So in order to use a for loop, we need the keyword for. And then we're going to need a variable to store our values to. So for num, in range, and then our range value controls how many times it will iterate. So if I type in 5, it'll loop 5 times. If I type in 10, it'll loop 10 times. If I type in 100, it will loop 100 times. And what happens is one by one, if I type in a 5 here, it will store the value 0 to num, then 1 to num, then 2, up to but not including the last value. A quick way to check to see what values are actually being stored to num is if we go ahead and output them. So if we're going to print num equals, and then we need to make sure we typecast this to a string, let's just go ahead and output our num variable. So when I run this, you can see it stores a 0, 1, 2, 3, and 4. So starting at 0 up to, but not including the upper bound, which we had as 5. But it does loop 5 different times. So if I were to change this to 10, and run it, it runs 10 times, but it goes from 0 up to 9. But that's not always how we count. So for instance, if I wanted to instead loop 10 times, but start at a different value other than 0, like 1, I can change my values in range. So the first parameter in range is the starting value. If nothing's there, it's assumed to be a 0. If something is there, then it will start at 1. So now if I run this again, I have 1, 2, 3, 4, 5, 6, 7, 8, up to 9, but this only ran 9 times. So remember, it goes up to but not including the upper bound, and therefore if I wanted it to run from 1 through 10, I need to change the upper bound to an 11. And there we go. So if I want to do something random, so maybe for some reason I want to start at 40 and I want to go up to 52. Well, I would need to put in my starting value 40, and if I want it to go up to 52, I need to go one more because it does not include that upper bound, and then when I run 40 up to 52. Now the last value we have for our range is our step. So if I want it to count from 1 up to and even include 100, but I want it to count by 5s, I would include this step of 5. And so if we run it, that's the easiest way to see what happens. We have 1, then 6, then 5 more, then 5 more, then 5 more, then 5 more. Now that might not have been what I exactly wanted. Maybe I wanted it to go 5, 10, 15, 20, 25. Well, I was off by 1. So it looks like I need to change my starting value here to be a 0. And then if I run it, now it goes 0, 5, 10, 15, 20. But what if I didn't want to count this 0 here? That's where we can go back and we can do an adjustment, and instead of starting at 0, we'll just start at 5. And there we go. So we have the options to play around with these 3 different values, which will then store different numbers back to our variable num. So that's our for loop. Then we have the while loop. For a while loop, we need an additional variable at the very top. So this is our starting value. So unlike the for loop, where in the range it had the built-in starting value, we have to come up with the starting value. And then while that value is less than a certain number. So this is like our upper bound. So it's going to start at 1, and as long as it is less than some value that we have here, we are going to then print, and we'll do the same thing. We'll do num equals, and then we will print out num. But the one additional feature we need that was built into the for loop is we need to then update count. So we create its starting value. We check to make sure that it's less than, greater than, that's meeting some kind of condition. But then we need to update count. So I want to take count and I want to add 1 to it. These 3 steps here essentially take and replace the part of range from the for loop. So now if I run my code, what do we do here? Oh, I output num instead of count. All right, so we run. We have 1, 2, 3, 4, up to but not including 5. The reason is because I use a less than. So I do have the flexibility. I could do less than or equal to 5, which then would allow 5 to be output. Or, like a for loop, if I want it to do up to but not including, I could change this to a 6. So we have more flexibility with how we control a while loop, in the fact that we can then change what our condition is. We could also, let's see, if we wanted to count from 1 up to 10, I'm going to use less than or equal to, but I want it to count by 2s. Instead of incrementing or changing it by 1, I'm going to change it by 2. So just like in the range that had those built-in parameters, we now have the flexibility to count by 2s, 1, 3, 5, 7, 9, with a while loop as well. I guess the one other thing that I didn't mention was if we want to go backwards. So we could count from 100 back to 1. We just need to make sure that we change the count, instead of being less than or equal to 10, that we want it to be as long as it is greater than 0. And then instead of adding 1, we're going to subtract 1. And so now it outputs from 100 backwards 99, 98, 97, 96, all the way down to 1. And we actually can do the same thing with the for loop. So if I do for num in range, just like I did before, and in my range, I can start at a larger number, going down to a smaller number, counting backwards. And that's how those parameters would look. So then if I print, I'll just do num here, we get the same outputs. We get 100 down all the way to 1. All right, so let's look at this assignment. So at the top, we can add in our comments. So you can do a 4-line comment here, add in your name, what we're working on, all that. And we have using a while loop to output the numbers 1 through 100, a for loop to output the numbers 50 to 65. So now we're putting into practice everything I just showed you. So if I want to add in a comment, I'm going to do a while loop from 1 to 100. So in order to use a while loop, we need our initial variable. So if I want to call it n, we're starting at 1. And then while that n is less than or equal to 100, I want to go ahead and print out n, but I have to make sure I also adjust and change n, or else I'll get an infinite loop because n will never change. And I can check over here, it outputs 1 all the way down to 100. So we're good. And you would do the same thing for the next ones. And if you don't want all these loops to keep repeating over and over again, we can comment them out. So we can do our multi-line comment here while I'm at least creating my next one. And the next one, we're going to do a for loop outputting 50 to 65. And you'll continue, you'll do your for loop for n in range, set up your range values, and then go ahead and play around with the different values for while, for range, in order to get those 5 different criteria output on the screen.
So strings are a type of data that is a sequence of characters. And in Python, you have lots of methods that come pre-installed for you to work on and work with strings. So this is a list of just a few of the most common string methods that you might see. And we're going to spend a little time today playing around with them so you have a chance to see how they work. But remember, if you are ever interested in learning more about these methods or learning more about string methods in general, there is documentation that is provided for the string class for Python, and you can look at all of these methods and their descriptions there. Okay, so here's the documentation of the Python string methods, and if you scroll down, you can see that there are lots of methods listed here. I want to point out just a few of them that you may find useful. So the first is the find method. Okay, the find method searches the string for a specified value and returns the position of where it was found. Okay, this is really useful if we have like an entire sentence and we want to know, say, if the letter I appears in there or the word the. If you want to be able to find different strings within a string, find is going to help you do that. But you'll notice that it returns the position of where this string was found, but it doesn't answer the question if the string happens to occur multiple times within the string that we're searching. And so we actually have a method for that, which is down here. It's called rfind. Rfind searches the string for a specified value and returns the last position of where it was found. Okay, so this actually, rfind is like reverse find, where it searches from the back of the string to find a substring. Okay, those are the two that I wanted to show you. There are others that you can play around with that you'll see in the course page, but let's try these out together so you can see exactly how they work.
Let's go ahead and take a look at how some of these different string methods work. So inside of our program, let's go ahead and type in Word, and we're going to write computer science rocks here. And so that is going to be our string, and we're going to see how we can use some of the methods in order to get information from the string. In particular, I want to look at find and rfind. So if I wanted to find in my word or my phrase here the letter O. So if I want to find that in my word, I first have to type in what I want to access, word, dot, and then what I want to do. Well, I want to find the letter O. Now, if I were to do this and run it, nothing happens because I'm not doing anything with this information. It is in fact finding O in computer science rocks, but then it's not storing it to any value. So let's call this location. And now if I want to find out where O actually is located, I can print out location. But let's have some more meaning to this. Let's see. The location is at, and then this is going to be a number, so let's typecast it as a string, location. So now if I run this, the location is at 1. So remember when we're dealing with indices here, and when we count, we always start at 0. So C would be the 0th position, and then O would be the first position, which is exactly what it told me. So let's say I type in a different letter, and let's type in a T. So I run my code, the location is at 5, 0, 1, 2, 3, 4, 5. Now it also does count spaces. Any character, that includes number, letter, spaces, all of those different things count as an index. So if I were to check for an S, and it says 9, so I have 0, 1, 2, 3, 4, 5, 6, 7, the space is at 8, and then the S is at 9. So it works. But it says that S is at 9. Well, what if I want to find where the last occurrence of S shows up? That's where we change find to rfind. Rfind will find it, searching first from the right-hand side. So find will find it, the first occurrence of it, on the left side, and rfind will start searching from the right and find its position as it first gets to it on the right. So this S is in fact at the 21st position of Computer Science Rocks. So now there's some other smaller things with strings and manipulating them that I want to talk about. So a string, for instance, word, we can do things like change it to uppercase. So if I want to change the word to all uppercase, I can apply the uppercase method. And then if I want to see how it is affected, let's type in new word. And let's go ahead and output it. Now it should be a string, so I won't have to typecast it, and I can do word. Uppercase, no. Oh, I think this is just upper. And this is where using the documentation would be helpful. In other languages, uppercase is a method, but in Python, they just call it upper. So now if I go to run this, I shouldn't get an error. But what you will notice is that it didn't change any of my things to uppercase. The reason is because, just like before, we are doing something with Word. This does make it all uppercase. However, it doesn't save it. It doesn't update what the word is. So if I want to update it, I have to make sure I save it back to Word. And so now it will take what was in Word. It will make it all uppercase. Then it assigns it back to Word. And now when I run it, it is in fact all uppercase. So I can do it uppercase. I can do, I think capitalize is one. There, it capitalized it. I think title was one we looked at, where it capitalizes the first letter in each word. So I want you to go ahead and continue doing what we did here. You can go ahead and change the word at the top. You can play around with different methods. So go back and look at that documentation to see what else we can do. Practice with find, you can use format, you can use count. There's a bunch of different things that you can play around with strings, but it is definitely something that you need to be comfortable working with the strings and the string methods.
The last thing I wanted to show you with strings today is I wanted to connect this idea of iteration with strings, because you may find it useful sometimes to actually iterate through a string. Python provides a nice framework for doing this. It's actually pretty intuitive. So if you remember in Scratch, to do looping through the letters of a string, you'd have to create your string and then create an index variable. You'd have to repeat for the length of the string, and then you have to use this block that says, say, letter index of my sentence. So that would actually use this index to go into each letter of the string. In Python, the for loop is actually built to automatically go through the letters of a string if that's the way you set it up. So you can create a string, and then in here, for your for loop, you would say for I in my sentence, which is the name of your string here, print I, and I will actually take on each letter. This is a very complicated idea in Python that basically is saying that this for I in blank means that anything that goes here, as long as it is what is called iterable, then, meaning you can repeat on it, then Python will figure out how you're supposed to iterate on it. So if it's a list of numbers, if it's a range of numbers, if it is a string, Python knows that for each one of those things, there's a specific way that you're supposed to loop through them and take on each value. So it's really nice for us as programmers that the designers of Python figured this out and made it easy for us to go through each letter of a string. Okay, so that's how you loop through the letters of a string. In the exercise for today's class, you have a couple of challenges to practice iteration. The first one is going to be creating a loop to repeatedly ask for a number between 1 and 100, and then exit the loop once they enter a valid number. So making sure that the person inputs something valid before you exit the loop. Okay, this is going to require some Boolean conditions to figure out when they have or have not entered a valid number. All right, the second exercise is going to be repeatedly asking the user to guess your favorite color until they get it right. Again, a loop that could potentially repeat forever until they guess something correct. And then the last exercise is asking a user how many numbers they would like to sum up, and then repeat that many times asking them for numbers, and then sum up those values and give them the answer. All right, and then Exercise B is going to be a little different. In this case, you're going to, instead of practicing coding, you're going to practice reading some code. So you're going to read through 4 separate programs and describe the functionality. These programs do not have comments in them because it's up to you to figure out what they do. But one way to think about how you can describe the functionality is to think about how you would add comments to them if you were the programmer who developed these programs. Because I know that you would add comments to all, and you do add comments to all of your programs. All right, those are the exercises, and that is your lesson on iteration.